Assalamualaikum. This is Hazrat, and we have successfully completed a project. My group members were Awais, Moise, Hassan, and our project was about Bitcoin price prediction. My part in this project was to build up the neural network and predict the prices. So let me show you the dataset. This is our dataset comprising of 2,375 rows. Uh, we made our dataset from 2016 till the current date, which is 3rd of July 2022. Uh, yes, you can see from here. The columns which we are interested are only two columns, which is the date and the closing price of the Bitcoin. So let me dive straight into the code. First of all, we have included the libraries, the NumPy library. It is a type of array, but it is a NumPy object. Uh, why we use it? Because make doing operations with NumPy array is much easier. We can reshape using NumPy array, and we can do many other operations. We use pandas library. uh, it is used to read the CSV data, and then we have matplotlib library. Matplotlib is used to make the um, graph like this one. Uh, then what we have done is read the CSV file, which is over here in the Google Colab, and then we are taking out the date column, and we are grouping the data frame by date, and after that we are uh, taking out the dollar price, the close price of the Bitcoin. uh, this is used to split the data. We have used 30 prediction days, uh, so that we can predict the Bitcoin price for the next 30 days. And then we have split the data into two parts, the train and test. The train data set will go from, this is list concatenation. The data will go from 0 up till, but not including, the length of the real price minus prediction days. So it will exclude the last 30 rows, and then we have the test, which will be from the last 30 days, which will basically, uh, if we start from last row and minus 30 from here, so the last 30 rows basically will be included in this data frame test df test variable. After that, we have included the data, we have split the data. Now we will process the data so that we can apply operations on our data set. We will first of all convert the data frame, train data frame, into an array. The values function will convert df train into array. Then we will reshape the data set. Reshaping means like converting a 1D array to a 2D array, and this is very easy using the NumPy library. NP is the NumPy object. NumPy.reshape, we have passed in the training set, and it will reshape accordingly. After that, we have included a library sklearn. From that, we have included a class min-max scaler. Min-max scaler is used to scale our data set between the range of 0 to 1. Why we have done that? Because our neural network uh, will process the data efficiently if it is in the range of 0 and 1. So min-max killer will scale the data set, and uh, we have then uh, training set, and then the training set of X label and X input labels, and training set of Y label, the outcome. After that, uh, this is all reshaping. Then we have included three libraries classes. One is sequential. Why we have included sequential? Because our data set is in sequence. Day one, day two, day three, on day four, this was the price, on day five, this was the price. So we have to include the sequential, and the sequential class will initialize our neural network. Then we have dense uh, class, which is basically a layer. And then we have the LSTM class. LSTM is basically used to memorize stuff that we are dealing with the sequential data. And long short-term memory, it is specialized in the sequential data. What it will do, it will memorize the data and feed back to the neural network. After that, we have initialized using sequential. We have initialized the sequential object regressor in the regressor of variable, and we have added the layer of LSTM. These are inputs. We have changed it accordingly to get the maximum accuracy using. We have used activation functions, and then we have uh, included the output layer dense, and the dense will only output one thing, and that is the Bitcoin price in dollar. That was the reason of including the dense layer to, because we want only one output, we want the price. After that, we have compiled our neural network using our optimizer and mean squared error. Finally, we have started the training of the data. We are passing X train, Y train, and batch size epoch. After calling this function, after running this, it will start to train the data. I will not run it because it takes time to train the data as we have very large data. Uh, After doing all of this, we need to make predictions to test how good was our neural network. We have taken out the DF test. Uh, the values will convert into the array. So this will, in the test set, we will have our testing data. We will reshape it accordingly, transform it, and again we are reshaping. Uh, the reshape will not change the data. This is very important. Uh, Regressor was, as you remember, it was our neural network, and we have called the predict function. In that, we have passed our input. What this will do is it will predict the price based on the data we have trained. And then we have called the inverse transform, which will basically return the data into the original form. As you have remembered that we converted our data into zero, between 0 and 1 range using the min max scalar. It was uh, I cannot see min max scalar. cannot find the line where we have transformed it between 0 and 1. Yes, here, we have transformed it, and then we are now converting it back to its original form. Then we want to uh, plot the data, and this was very interesting. Uh, Basically, there are two important lines over here. Plt.plot. This will plot the real BTC price in the red color, and then there is predict BTC price using the it is in the blue color, and these are all we have added the title, Bitcoin price prediction, and legends, and X label, Y label, but these two were the important lines. After that, you can see the level of accuracy we have gained using RNN neural network. That was it. Thank you very much.